All right, everybody, it says that we're live. Hopefully everything is running fine. I hope everybody can hear me correctly. And we'll get started in a second. Let me actually refill my water. Completely forgot that. Everything. Yeah, there we go. Okay, now I'm really ready. Cool. Hello, everybody. We're doing something different today. And this is very exciting because, yeah, we have hopefully an audience over in the University of the Basque Country, where hopefully a whole bunch of students have gathered to watch this presentation. And I hope everybody else who's also joined us is going to enjoy what we are doing today. So, welcome to the first part of a two-part workshop, just as an introduction into using Godot for VR. Now, as I said, this is being watched by students of the faculty or of the University of the Basque Country, and they have graciously sponsored this this stream. So yeah, just to to the script that they gave me here. This talk is supported by the Faculty of the Informatics at the University of the Basque Country and its Masters in Computational Engineering and Intelligence Systems. The event is organized by the faculty's 3D Extended Reality Lab, Morgildu. I hope that I pronounced that right, because that was an interesting name. So I do want to tell everybody who is watching the stream live that I will not be keeping an eye on chat. I am going to run through this workshop, this presentation, and I won't really have time to answer questions. There will be a Q&A at the end. And I believe that I've already said this in the description of these, or in the announcement of this. We will obviously be giving priority to questions that are coming from the students. But if there's more time, then we'll pick a few questions that were answered or asked in chat as well. So let's get started. So we have two sessions. Today is the first one. Tomorrow is the second one. And in the first session, we're going to have a bit of an introduction. I'll tell a little bit about myself. I won't go too far there, but just so that everybody who is watching this has an idea of who I am. We'll have a small overview of what Godot is. I'm hoping that most people who are watching this are already familiar with Godot. But it's still good to sort of set the tone and sort of give a bit of an overview. We'll also have a bit of a talk about Godot and its role in the XR industry. And then finally, the main part of today is that we're going to use Godot XR tools to create a small XR application, just to sort of give an idea of how you get started with a project in Godot, and hopefully to give people sort of like a jumping off point if they want to do stuff in VR. Tomorrow, the focus will be more on AR. So we'll have a bit of a talk about the AR capabilities of Godot. And again, we'll do a workshop where we will build a simple AR application in Godot, where we're going to be using mostly meta scene discovery so that we can interact with our environment. So that's the plan for today. All right, let's get started. So who am I? Well, I am Bastiaan Olij. I am situated in Sydney, Australia, originally from the Netherlands. So yeah, that's I think I've been living here for about 18 years now. So yeah. I'm the lead XR developer for the Godot engine. About 8 years ago, I started, well, probably 9 years by now. I started with adding XR support to the Godot engine and sort of rolled into the lead developer role for XR. And we now have a nice little team of people who are either working for or volunteering for adding support in XR. I'm also a board member of the Godot Foundation. So the Godot Foundation is an organization that looks after the development of Godot, just to make sure that everything runs well, that we have policies in place and that sort of stuff, and also interact with donations and make sure that the donations are used properly and used for development of the engine and that sort of thing. I'm also an individual contributor on the OpenXR working group. Sounds very, very cool, but it is Not that special. Well, I kind of find it special, but it's not, it doesn't entail that much. It means that I am part of the OpenStare working group. I'm part of the discussions and put my, my opinion up for things that are added to OpenXR from a point of view of a game engine. But I don't have any rights or say other than, people for some reason listening to me, which is kind of nice. For the last 5 years, I've also been a full-time contributor to Godot. I am being paid through several grants that we've received over the last couple of years to basically make sure that the XR support in Godot keeps growing. So that's me in a nutshell. There's some links on there to, anybody who wants to send me an email, feel free. I always like hearing people who use Godot for XR things. There's a link there to my YouTube page, which I'm guessing if you're watching this stream, you already know, but handy to have. And I generally use Blue Sky to do announcements of whenever I put a video up or whenever I put a new stream up. So you're welcome to follow me there. Okay. So having a look at Godot itself. Godot was originally developed by Juan Lenetsky and Ariel Monsier, two guys from Argentina, if I am not mistaken, who have a long history of making games and working in the games industry, built a number of game engines over the years, and eventually that evolved into Godot. And then in 2014, decided to open source this game engine. And that is the main thing about Godot is ever since 2014, it's been out there in the open. Anyone can use it. Anyone can contribute. Anyone can be involved in its development. And it's sort of skyrocketed ever since. Very important is that Godot is licensed with the MIT license. And the MIT license in a nutshell means that you are completely free to use the engine. You don't have to pay us anything. Obviously, we love it when people give us donations, but you don't have to. You don't have to open source your own games or your own creations. You can use it completely in a commercial environment. Really, the only requirement with MIT is that you credit us for the fact that you are using the engine. So somewhere in your application, you need to have the license accessible by your users, and that's really all that is there. There is probably a little bit more that I'm skimming over, and there's a really good page on the Godot documentation because there's some third-party things that we use and stuff like that. But in a nutshell, that really is it. It really is free to use, and you can do that. The other thing that we are very, very proud of is that it's also very small. The download is about 80 megabytes. It obviously extracts to slightly smaller, bigger, but it is in that order. And that gives you the complete editor. There is a secondary download for templates. So every platform that you deploy to, there is a runtime template. So that one is a little bit more sizable because it's basically 10 copies of Godot. But still, compared to other engines, it's a tiny, tiny engine. It's also fully written in C++, which I'm a big fan of. But yeah, nice thing to know, especially if you want to help out with Godot and contribute to Godot. It's a C++ engine. Godot 4 was a relatively recent rewrite where we focused on a new rendering engine that was using the Vulkan rendering pipeline. And that is basically the essence of the engine. However, nowadays, it is possible to run Godot with DirectX. It is possible to run it with Metal. It's possible to run it with OpenGL. So all those are supported, which also is very handy for different platforms. Out of the box, Godot supports 2 languages. It's inbuilt GD script, which we will be looking at today. But if you are more comfortable programming in C#, it is also completely possible to use C# with this engine, and it's well supported. So those are the 2 that we have. But there are other languages that if you want to program in, say, Rust, there is a plugin available to develop Godot using Rust. And there's several others as well. I'm not completely into that, but I know that is possible. Very important thing for us is Godot works, well, everywhere, nearly everywhere. All the major platforms are supported, so Windows, Mac, Linux, iOS, Android, and HTML deploys are named here. And the nice thing, even, as I say in the blurb here, we can even run the editor on certain XR devices. So it will run natively on the Quest, and we're working on bringing that to other devices as well. So yeah, it is incredibly portable. And because it's so small, it's also easy to just use on the go. You can install it on a laptop. You can even install it on a tablet, and you can use Godot while you're on the run. Obviously, we are talking about XR in this presentation. And as I mentioned, I originally started with XR support about 8 or 9 years ago. We started with just OpenVR support that eventually migrated to mostly being OpenXR focused. That is really the standard that we are using today. And in engine, in the core of the engine, WebXR and OpenXR are both available out of the box. There are abilities to use plugins to still go to OpenVR or to use something like a Tilt 5. But in the engine itself, we are very focused on the OpenXR ecosystem. Again, XR is supported through OpenGL, Vulkan, DirectX, and Metal. So that is that means that many of the devices that are out there today will run Godot in an XR form. Last but not least, ARKit and ARCore, there are plugins available, but they are still very much under development. But if that is something that you're targeting, then that is available. But there is a lot of requirement to understand a little bit more deeply the engine to use those. VisionOS is currently available purely for 2D apps, running those in Windows. And we have a immersive VR version ready as an experimental version, which basically means that there's a PR available that you can run, but it's not yet part of the official offering of Godot. And I can't give any timeline there because that is the way that open source works. We get functionality together. It will be submitted as a PR to the public, and then the community can weigh in and do something there. Okay, what the heck is going on here? Someone is being crazy. Don't know why Godot Byte is spamming chat. If he keeps doing that, then I do have to remove you, Godot Byte, because that is not nice. Anyway, he seems to have stopped, so keep an eye on it. All right, here's a couple of examples of games that are either out or in development. So we have on the top left, oh my God, Stellar. Now I forgot the name, but it's a Papers, Please like game that you can play, but it's in a space station and it's in VR. It's a lot of fun. Endoparasitic is a game that was released a little while ago and has a VR version right now. It's a really interesting horror game, so worth checking out if you want to know what sort of things are working in Godot. Penguin Festival is the little penguin game that you see there, which everybody is really enthusiastic about and hoping that it will soon be released. I do not have a release date for that, unfortunately, but the developer is very prolific in showing what he's doing and what he's working on, and it looks absolutely splendid. So was my cat. Sorry, I know that I'm not supposed to keep attention on chat, but I had to laugh about that. I know exactly how you feel. I have a cat as well, and it's jumped on it's actually jumped on the power button of my computer once, so that was really annoying. Anyway, sorry for the distraction there. The third game, or the fourth game on this list, is a Fall Guys type game that is currently in development, but then in VR. The game here is a game that a long active developer in the Godot XR community is being worked on, but I don't actually know if it has a name yet. But it is, if I remember correctly, it is a zombie shooter, but another really cool game. And the last one, which was in the news not that long ago, is D-Day VR Museum. Check it out if you're interested in history. It's an amazingly interactive museum type application where you can learn all things about World War II and specifically D-Day. So these are 6 examples of games that that are currently out there. There is more out there, but these were a few highlights that I just wanted to show as an idea of what sort of VR games you can make with Godot. Other than that, we have an official Discord for Godot Engine, and there's an XR channel on that official Discord, and that's where you find most of the people who are developing XR things with Godot, and it's a really nice and really friendly community. So if you need a little help, that is a really good place to join and to ask around and you know make some friends, I guess. So something that we will be mostly looking at today is Godot XR Tools, which is a foundational toolkit library that implements higher level, specifically VR focused functionality. So out of the box, Godot is like a Lego box, right? It has all the Lego pieces with which you can put something together, but you still need to implement higher level logic on top of that. And that is XR Tools. So XR Tools gives you logic for locomotion, so the ability to move around the world. It gives you logic for picking up objects or interacting with objects. It has a number of user interface elements and you know, that sort of thing. So it's a toolkit that allows you to get started really quickly without having to know a lot of what needs to be done under the hood. OpenXR itself, like I said, is something that is supported in the core engine. We have been OpenXR centric for quite some time now, but there are a few things that we cannot do in the core, specifically when it comes to vendor extensions. So when we look at OpenXR has 2 sets of functionality, so to speak. One is its core functionality with what they call a multi-vendor extension architecture, where it basically defines everything that OpenXR can do and what an OpenXR headset should do, and that you're guaranteed to have support for within limits, within the capabilities of the hardware that you have. And that's all implemented in core. But there's a second part to that, where every hardware vendor can submit their own extensions for functionality that is only available on their headset, or for which there isn't a standard yet and they want to expose logic for their own system. So a good example of that is tomorrow we will be looking at AR with our Quest. And we will be looking at Meta's Scene Discovery API, and that is one of those vendor extension API. So those are not part of the core offering of Godot. Those are implemented in a first-party toolkit called the OpenXR Vendor plugin, and we will be using that one tomorrow. The next point here is very interesting for our audience today, and that is that Godot is getting more and more interest from education and research institutions. It is a really well fit because of its open nature. So yeah, I'm hoping that the people over at the university are going to have fun with this and learn some things and do lots of things with Godot going forward. And yeah, the last one I kind of already talked about, but is the topic for tomorrow, is that we have support for Meta Scene Discovery and OpenXR spatial entities to bring AR functionality to Godot. The other thing that we are really proud of, and I did mention it already a little bit earlier on, is that the editor even runs on a headset. And right now the focus is still on Quest 3. We have it running on other headsets, but there are some functionalities that we're still waiting on for that the vendors for those headsets still need to implement in their system. But on the Quest 3, this works really, really well. One of my colleagues, David and Logan, did a game jam a couple of months ago, and you can find it on Logan's YouTube channel where he talks about it, where they implemented the entire game just using the Godot XR editor running on a Quest. They did not use any PCs. The only thing where they used a PC was to transfer some of the assets from a PC onto the headset, but the rest was all done on the headset, just to prove that you could build a full game on the headset. One of the big advantages in building on the headset is that you don't have to keep putting the headset off and putting it back on, and that is something that a lot of people find very uncomfortable. So keeping your headset on while you're developing, a lot of people enjoy that workflow. So something that we're quite proud of, that is something that we are offering. Let me just get a quick bit of water. So I've already talked a little bit about XR tools. That is the toolkit that we'll be using today. It primarily focuses on VR functionality, but you can use it for AR applications as well. It is a toolkit that was built to sort of pick and choose which parts of it you want to use. I've been developing it almost as long as that I've been adding XR functionality to Godot. But yeah, it's available. It also is offered under an MIT license. So same thing applies there. You can you're completely free to use it in any way you see fit. There are other alternatives. One of the limitations of XR tools currently is that it is GDScript focused. So if you want to use C#, you might run into some difficulties. You can mix GDScript and C#, but there are some rules and limitations there. But there are other similar toolkits that other developers are working on, including one that is completely built in C#. So we're going to look at XR tools today, but there are other ones that you might want to look at in case they meet your needs a little bit better. And yeah, the last remark, it is not mandatory. You can build everything yourself and customize everything yourself to your own needs. It is just a toolkit that allows you to hit the ground running. But yeah, if you want to do more yourself and want to learn more, there's a lot of content on my YouTube channel and that of others that show how things are being built and where you can learn how you could reproduce things yourself. So with that, we are at the end of the quick presentation, just as an overview, and it is about time that we go and have a look at Godot itself. Just having a sneak peek if Inigo has got any remarks for me, but it looks all fine, so I hope everything is good over at the other end of the line. Cool. So, live starts, obviously, on the Godot engine website. A nice place to look around a little bit, but you can immediately find the download button for the latest version here, and you just go to the download over here. Now it should select the right version for your operating system. We are going to be using the Windows version of Godot, but you know, you can, like I said, you can run this on Linux or on Mac OS as well. Now, the only thing that is really important to know when you're working with XR, we are going to be using my Quest 3 today for this presentation. Cool. And in order to make things run on the Quest 3, there are basically two ways of doing it. One is you can run on the Quest 3 itself. And that is something that we're going to be doing tomorrow and showcasing tomorrow when we are doing AR things, because that requires the software to run on the headset itself. But for today, I want to run in what is called PC VR mode. That means that your application runs on the PC and you're streaming everything to the headset to display it. Now, when we're looking at streaming, Meta themselves have a tool called MetaLink, but that is a tool that only works on Windows. So if you want to use Meta's software, then you need to obviously be on Windows. You can't be on any of the other systems. We are going to be using Steam Link today. Steam Link is basically a similar sort of application as MetaLink is. It just runs through Steam. And again, it has the same functionality. It allows us to run our application on our PC and then stream to the headset. Now, Steam Link works on Windows and it works on Linux. But on Linux, there isn't a support for using the Quest 3 with that. So, and I'm not sure that that is something that I think they are working on. So I might be lying there if that they've already implemented that. But as far as I'm aware right now, you can't use Steam Link yet on Linux. However, there are alternatives. For instance, ALVR is a system that allows you to run the headset in this way on Linux. And another application is Wyver. Yeah, indeed. The message in the chat, Metalink, is unreliable. There are some nice things about it, but I have found Steam Link to be more stable. So yeah, ALVR and Wyvern are options to do streaming and development over streaming on Linux. I am not entirely sure of what the ecosystem currently is on Mac because I don't use Macs in that way that much. But I do know that someone is working on a streaming application that allows you to use OpenXR on a Mac and then stream to a Quest or another standalone device. So there are options there. But today I am looking at using a Windows machine with Steam Link to stream to the headset. Now, if you really are in a situation where you cannot use that, everything that I'm showing today is still applicable, still everything that allows you to build the application that you want to build. But then tomorrow, like I said, we're going to talk about how do you now deploy onto the headset itself. And that can also be done with everything that we do today. I just want to be mindful of the amount of time that we have. So yeah, that is the thing that is important. The Windows ecosystem, you know, as far as XR is concerned, there is just more available on Windows. Obviously, I've already downloaded the engine, but basically when you download it, you get a zip file, you unzip it, and you have an executable, and that's all. So when we look at starting Godot, we're getting this nice little window. Now, I've prepared just the skeleton of the demo today just to save us a whole bunch of download time. But normally you obviously wouldn't be seeing this. There will be a message that you could go into the asset library. And I'm just showing this off just to go there because there are some entries in here if you search for XR that are interesting to check out. The Godot XR templates is a really nice project to check out and to create a new project from. Yeah, I do believe Visual Desktop works on Linux, but I'm not too familiar with it. Well, not too familiar with using it. I am familiar with it existing. Anyway, so the Godot XR templates project is an entire sample project using XR tools with a loading system embedded that you can use as sort of like a springboard for a more complex application. You'll also see that there's a bunch of sample projects in here, and XR tools wise, there's also a full demo in here. So yeah, there's quite a lot of projects to go and check out and to play around with to get a bit more of a feel. But we're going to create a new project today. So we're skipping the step today, but I will show it. You would then go to create over here. That opens up this little dialog here. You can provide a location on disk where you want to save it. You can give your project a name, and you get a choice of what renderer you want to use. And that is where a lot of people go like, yeah, but I don't know, you know, I'm new. I don't know what choice to make. So in a nutshell, the choices are from top to bottom, the Forward Plus renderer, which is our advanced desktop renderer. So this is the type of renderer that allows you to do fairly realistic looking graphics. But it really requires a beefy PC to run. And when we are looking at XR applications, especially when you're running on a standalone device, this renderer is not applicable. But if you are making a PC VR game, this is definitely a solid choice. However, you do then require to run on beefy hardware. So most projects will actually be using the mobile renderer. This is sort of our stripped down renderer that is more specifically targeted at mobile devices. So this renderer runs really well on the current generation and future generation standalone headsets. It runs really well on PC VR mode, so this is really great if you want to make an application that you want to run both on PC and on standalone. And it's really, especially with the new 4.7 coming out, where we fixed a few more performance issues, that is a really solid choice. Today, however, we're going to use the compatibility renderer. These two renderers are using the Vulkan/DirectX backend. The compatibility renderer is using an OpenGL backend. It is a fairly stripped down renderer that is really focused on low-end hardware. So it runs really well on standalone devices. This is going to be important if you want to run on a Quest 2. It runs really nicely on a Quest 3. And obviously it's going to be running really well on more modern hardware as well. So that is the one that we will use right now. And normally you would therefore press create, and that would create your project, and away you go. Now, like I said, I have already created this project because I wanted to already download a few things. Let me just close these things. Those are for later. So normally you would be presented with a completely empty project. But you'll see that I've added a few things in here. And the first thing that I've added in here, so the first thing that I recommend everybody to start with is going to the asset library and looking for XR tools. Come on. Okay, it's a bit slow, probably because my network is doing too many things. But if you type in XR tools, you will find XR tools downloadable here, and you simply click on it and it'll have a download button, and that will install XR tools for us. I've obviously already installed it. It will place it here in add-ons, Godot XR tools. And sadly to say, obviously it's not happening right now because I've already got it. But the first time that you install it, you will see a lot of errors and messages in the log here, because by default, XR tools is not enabled. So we open up in project settings, this window, and the first thing that we do is we go to plugins here and we enable it. And I realized that I forgot to update the version number there. I need to make sure that I do that. But yeah, you enable XR tools here, and that's really all that you need to do. Now, what we also need to do is a couple of changes here in the general tab to set up our project. Now, the first thing that we're going to go to is we're going to go to physics, and we're going to go to 3D, and we see that now by default our project uses the Jolt physics engine. Now, the Jolt physics engine is a really, really good physics engine for physics interactions that was added to Godot fairly recently. It's an engine that was built by Gorilla for Horizon Zero Dawn, and that they graciously open sourced. However, XR Tools is currently not optimized yet for Jolt, because XR Tools has been around a little longer. So only because we're using XR Tools today, I am going to switch back to Godot Physics, which is actually our default. But that's just because we're using XR Tools today. I'm working on a new iteration of XR Tools that is properly using Jolt. But for today, we're going to the default. Tomorrow, when we're doing our AR stuff, we are not going to use XR Tools, and we will rely more on the Jolt physics engine. For this sort of things, they are very close, so it's not a really big thing. The other thing that we need to do is scroll all the way down to this XR section, because we need to make sure that OpenXR actually runs. And the first thing that we do is in the OpenXR session here is at the top where it says enabled, we tick the tick box, and this will tell Godot that OpenXR needs to start at the beginning when you run your application, and it will set up everything for you. There's a few other settings here that we should change right away. Most of these are already correct. For XR Tools, we're going to keep the reference space at stage. I will talk a little bit more about the reference space later, but the other option that for VR and AR is a viable option is the local floor option. And like I said, we'll talk a little bit later about what that does. The environment blend mode is something that will switch the headset between VR and pass-through mode. And again, that's something that we're obviously going to use tomorrow, where we're going to go and set this on alpha. And I'll talk some more about what the differences between additive and alpha tomorrow when we talk about AR. Now, these two settings are very important to get right by default. So we're going to set our foveation level to high, and we're going to enable dynamic foveation. Now, these two settings are primarily targeted at Quest, although other headsets have been starting to implement support for these as well. But they enable support for foveated rendering on the headset. And foveated rendering is a technique where what is in the center of the screen is rendered at a higher detail than things at the edges of the screen. And that saves a lot of performance. If you have a device that has eye tracking available and it is supported, it will even go as far as that the part of the screen that is rendered at high definition, at the high resolution, is where the player is looking at, which gives an even better experience for the player. So these are just really good settings to enable. The dynamic option, by the way, changes how strongly it applies that area that is in higher resolution, so that if the device is under load, it will constrain this a little bit more and it will free up more resources that way. So yeah, a really good way to make sure that your headset runs at a good performance. Now, there's some other options here that I would really recommend you look through once you get a little bit more familiar. But yeah, there's a bunch of other extensions that we can do. So we'll be looking at hand tracking tomorrow because we will be using that for AR, but we're not using that right now for VR. Here's our spatial entities settings. So we'll have a talk about that tomorrow. But yeah, the rest is not really applicable. One other thing that's important is right now I have not installed the vendor plugin yet that I talked about earlier. The vendor plugin is required to push out things to the headsets and to enable those vendor extensions that I was talking about. So obviously when you install that, there will be additional options in this list as well. But today we're just sticking to PCVR and we're not using any of the vendor extensions. So I'm leaving that out. Now, the last setting that we need to change is in shaders here, that we need to enable our XR shaders, and that just adds stereoscopic rendering support to the engine. All right. Save and reload. Okay, cool. So with that, we have our XR tools installed. We have Godot configured correctly so that it can run an XR application. Now it's time to start building that application. Because we're using XR tools, I am going to start using parts of XR tools that allow me to immediately have things set up. So saves us a whole bunch of manual stuff. But that is important to realize that there are two ways that you can use XR tools. One is that if you want to do a very straightforward application, is that you just create a scene. In Godot, everything is organized in scenes. That gets loaded at the start, and that has your application in there. There is also a system in XR tools that is called the staging system that introduces its own startup scene and has logic to easily switch between scenes within the XR space. So this is sort of an approach that you would want to use if you want to jump between different environments, or if you're making a game, you want to go from one level to another, or you want to switch between a menu environment where you're setting up your game and the actual game itself. And that's what we are going to be using today. And the nice thing about using the staging system is it suddenly sets up a whole bunch of systems for you, and you can just use those. Now, with XR tools, we are using what is called inherited scenes a lot. So there will be a scene defined in the library itself with all the base logic in there. And we will create a inherited scene on that, which means that we're creating a new scene, a new entity that we can work with that inherits all the behaviors of the underlying scene. We have a folder here called staging. and we have a scene here. So everything that is a scene is recognizable by this extension called TSCN. And we're going to right click on that, and we're going to go and say new inherited scene. Excuse me. My nose is giving me a bit of problems. All right. So we see a whole bunch of things in here that we don't really need to talk too much about, because this is all set up. Now, the ones that I do want to quickly point out is this one all the way at the end, which is the start XR node. And that has a start XR script. And that contains all the logic for initializing our XR application. And if you do not want to use the staging system, but you want to just create a application directly for yourself, or I should say just a single scene application, I would still recommend adding the start XR script as is into your main scene, because it allows you to run through the whole startup logic without having to worry about that. It gets that all as a bonus. The other parts that we see here are all parts that have to do with the loading scene. So it's basically a scene that we see whenever we are switching between the actual levels or environments that we want to use in our VR application. Right now, by default, it is nicely bland window here. So we need to set a few things up here. So one thing that we can do is actually put a splash screen in here, and I just realized that I probably don't have a splash screen. So I'm just going to go and put the big our icon there. Should have prepared that one better. I think we do have a splash screen in our demo, but I don't have it handy right now. But the idea obviously is that you put your own image there, and that is the image that the user will see when the application is booting up. Yeah. The other thing that is then important is that this loads up. We see our logo. We see here a little progress bar that shows us how far we are in loading the actual environment that we want to use. And then we'll see when we run this, that when it's loaded, we don't immediately go there. There will be a message that will say like, hey, user, please press a button on your controller before we actually start our application. And in here lies a really interesting conundrum when you are building VR games specifically. We'll see tomorrow that in AR, it's a little bit different. But in VR, because you're in an immersive environment, because you don't see the real space around you, you can start anywhere within your environment, depending on what the headset thinks is the center of your play space. And this is something that a lot of people get wrong, and a lot of developers get wrong, because they sit behind their computer, they're developing their VR game, and a headset like this, whenever you, especially in Quest, whenever you hold the Quest button on your controller for a number of seconds, will recenter the player to be at the center of the space that they're in. So it will now say the center of my play space is where I'm sitting. However, you now start building that, so you are always starting at what you think is the center, and you're really, really happy, and now you give your game to someone else or your application to someone else, and they start it up, and they might have last recentered when they were behind their computer, and now they pick up their headset and they walk to the middle of the room, and all of a sudden they're 2 or 3 meters away from that center position, from where the headset thinks the center of the room is. And obviously that's not good, because your game might not want you to be there. 2 meters away from where you're sitting right now might be a locked off room, or you might be above a cliff and fall down the cliff or something like that. So one of the things that we do here is, first of all, and you can kind of see it by, how big this environment is. If I zoom in on my player, that's a really big screen here. So what we've done here is create an environment that is so huge that it doesn't really matter where you are standing in relation to the center of your play space. you will always see this big screen in relatively the same position. But when you then load into your game, we can now say, hey, the user is standing, the user is starting the game, he's pressing a button, so we know now where the user is, and we're going to recalibrate where the user is, and we are going to determine that starting point to be the center of my my environment that the user loads into. So that is one of the things that we are doing here, not just offering up a loading screen, but also offering up a mechanism to make sure that the player actually starts at the center or at the starting space of a level or an environment. That is also one of the challenges when you are not using something like the staging system, but you are creating your own scene directly. You don't have that moment. So you have a big chance that your player will be in the wrong spot for your game at the start. So you'll have to figure out your own way to deal with that. Now, the other thing that we do at the start is I'm currently sitting down. I want to make an experience where the player is standing up, or the character in the game is standing up. So the other thing that we do is just like figuring out where the center of our play space is. We're also figuring out, okay, the user has his headset on, he's pressing the button, how far from the ground is he, and how much do we need to adjust our character so that the character is actually standing up, even though the person playing the game is sitting down. So that's another thing that we are doing. Cool. So by itself, this has all the functionality for showing that loading screen, for loading in an environment, and then switching over to that environment. Obviously, we don't have an environment right now, so our next step is to actually create that. Actually, our next step first is actually saving this. So I'm going to rename the root node to main. I kind of like that. That's a personal preference. And I'm now going to save this into the root of my project, and I'm just going to call that main scene, and I am happy. There we go. So now I need to create our first environment. And for that, again, I need to use inheritance, and we're going to use this scene-based TSCN to create our first environment. So let's call this our test scene. And we are again just going to save that already so that we have it. And I like to create a folder here for all these stages that we create. I call them stages, but you can call them whatever you like. And I'm going to call that test scene. And I'd like to put this into a folder so that as I create additional environments that my user can go to, each one is in its own little folder, and I can also store, subscenes and additional components in those folder that belong to that specific stage. All right. So with our test scene created, we can see that we have a little bit of default setup here. We have an XR origin point. This is the XR origin that will take over when this scene is loaded. So we saw that there's another XR origin here in the main scene. This is used when the main scene, when the loading scene is shown. So the XR origin is the node that references the center of our play space in our room to a place within our virtual world. So right now, in this scenario, I am standing exactly above that play space, but when I start moving around the room, that point stays where it is. That always maps a fixed location in my room. It's just where that location is defined is a little bit different depending on which reference space you use. But once your game starts, that position should never change as far as the virtual relationship is, or it should never change by itself, I should say. When the player then moves, the only thing that we are actually tracking is the headset itself. We have no idea about the player's body. We don't have any sensors on the player's body. All we have is the player wearing the headset, and the XR system tracks where the headset is inside of the room. And that is shown, or it results in this XR camera 3D, which represents the location of our headset, moving around the world. So as our player walks forward, we will see, oh, is it this one? No, this one. Yeah. As our player walks forward, we will see the camera slowly move forward and forward and forward and forward, while the origin point stays over there. So that is an important thing to realize. A lot of people think that the XR origin point is where the player is, and that is the wrong assumption. The user, the player, again, depending on whether you're making a game or whether you're making an application, the only thing that we know is where the headset is. And we can infer from there where the player's head is. We don't know much more about the player. If we want to move the player through the virtual world, there's another problem. The XR camera 3D tracks where we are physically in relationship to the origin point. But if we want to move the player around the virtual world without the player physically moving, say that you want to move around a world that's bigger than the room that the player is in, or you want to allow the user to move around while they're sitting in a chair, you need some alternative way to move it. And we're going to start looking at that in a minute. But for now, I just wanted to mention that that is a situation where we control the origin point. So the player might have walked a little bit forward, but then if we want the player to move further than that, we can move the origin point with some sort of input. In that, there's also a problem. If you want to turn the player, you obviously want to turn the player around where it is, but if you simply turn the origin point, you can see that suddenly the player is swinging around the room like crazy. That's obviously not something that we want. That is important if you're building everything yourself, but it's logic like that is all built into XR tools for you. So we'll see that just working in a minute. All right. So we have our main scene, we have our initial test scene. We're not done with our test scene, but I want to quickly go back to the main scene to do one final thing. And we actually see a triangle here already that is warning us about it. We do need to tell it what the first scene is that it needs to load. So we're going to open that. We're going to stages. We're going to test scene, and we're going to select our test scene. And that makes sure, and unfortunately that warning doesn't go away right away. I need to look into that. Now we have told the system, okay, you're going to go into our loading system. You're now going to load up our test scene, and it'll take care of all the switching logic that we need. So that really is everything that we need to do on our main scene. On our test scene, if I run this right now, and I'm not going to do that yet because it would just be very dark, we have, well, actually, that's the problem that we now need to solve, is that it will be very dark. And the reason for that is Godot organizes everything in scenes. So we have already created the main scene for our start environment. We've created our test scene for actually our run environment. But we will soon be adding other things in here that could also be scenes in themselves. So even though we see a horizon here, and if I go and look, yeah, there it is. If I look up, I will find a sun here. The editor has added that into our scene so that we can see things, but it's actually not part of our scene. And that is an important thing to realize, because without that, obviously, we don't have any light in our scene. So we actually need to add this environment. Now, luckily, Godot has made that very easy. With our root node selected, we can see here, we can actually see that we can turn everything off. So this is actually what we would have seen if we would have run this. But we can go to these three dots over here, and we can see, first of all, the setup of this environment. But we can also quickly click on Add Sun to Scene, and then Add Environment to Scene. And now this environment has become part of our test scene, which means that when our test scene loads, that's actually our horizon that we get, and that is actually our sun that we get. Now, the other thing that I want to do real quick, just before we run this for the first time, actually the next two things, the last two things before we run this for the first time, is I want to create a floor. And I'm going to run ahead of myself a little bit and start with a static body. And we are going to add a collision shape to that. And we're going to give that a what's called a world boundary shape. And this basically means that we are creating a collision environment on the floor of our level, of our world. And that will prevent that once we start using physics to move the player around, the player won't start falling endlessly down into the ground. So right now, in our first step, we're actually not using that yet because we haven't enabled any physics logic yet. But just to prepare that, I'm already putting it in there. What I do need right now is what's called a mesh instance. That is an entity that allows us to render something. And we then need to set what we need to render. So under mesh here, we are going to create a plane mesh, and we can see a tiny little square there. Now I want that to be a little bit bigger. So let's make that 100 meters by 100 meters. And now suddenly we have a floor that we can see. And that's just so that we're not floating in this big open space. We're actually standing on something and we have something to see. I want to quickly give this a material as well. So I go down to material over here and I'm going to create a standard material. And all that I quickly want to do is under this material, under this option albedo, is I want to give this a texture. So I'm going to give it that pattern texture. Now that pattern happens over the whole big thing. Actually giving that quickly a color so that we can actually see that pattern. I like to make that a bit green to simulate a grass field. But we can see that that pattern is way, 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 way big when I'm coming in here. Those are way too big. So we're going to go scroll down. We're going to go to our UV section and we're just going to up. Those are linked. That's right. I only need to change one of those and the other two change with it. So I'm going to up that a little bit to just create this checkerboard pattern, which just gives us something visual to see and gives us a bit of an idea about size. Now, the second thing that I want to do is we can see in our standard setup here that we have a left hand and a right hand controller node. Are they controller nodes? Yep, they are controller nodes. And similar to the XR camera tracking where our headset is, these controller nodes are going to track where our controllers are. Now we'll make something nice out of that in a minute. XR Tools has some beautiful features there, but for now we are simply going to visualize these with a little box. That is way too big, so I can adjust the size of that box over here. So let's make that 10 centimeters squared. There we go. We have a little box. I'm just going to rename that to test. And now I'm going to go and copy that onto our other hand. So we can see, and this is, by the way, something that I glanced over just now. We have a default location for our camera. It's way up here. We have a default location for our hands over here and over here. But once we actually run our application, those will be overridden by the actual tracking data. So it doesn't really matter where we place these. We are just purely placing them to make our editing a little bit easier so that we can see where things are relative to each other. But once we start running, we will see that these things start moving. So if I've done everything correct now, we should have set up enough to get our first bit of application running. Just to make my life easy, the first time I run things, I'm going to select the scene that I want Godot to use by default. Don't have to, because I do have the option to do a selection. But you'll see that the first time that I run it, and an application, when you want to run your game in PC VR mode, and the same happens if you want to run a normal game just on the PC itself, you use this play button in the right top hand of our toolbar, or you press F5. There's a hotkey there. And then when we run that for the first time, it says, hey, you don't have a main scene yet. I don't know which scene to run. Which one do you want to use? Do you want to select one, or do you want to select the current scene? So this is why I made sure that that main scene was selected, so that that is the scene that we run by default. So I select current, and I'm just going to go and move that over here so that we have it a bit bigger. And see, that's why is that not working? Okay, that's strange. What's going on here? Something's stuck. Oop, no, that's not what I want. Ooh, something went wrong. Why did you go wrong? That is not good. What did I forget? I forgot a step, I guess. Start XR node is active. So I don't have a start XR node, which is that node over there. Why is that not there? What am I missing? XR start node is getting there. On ready, we're trying to find that. Is that the problem? Hold on. We have our user settings. We have our Rumble manager. Okay. Went wrong over there. So it's not finding this one. Always something that well, goes, of course, astray when we do a demonstration. But this is interesting because that would suggest, why are you finding? Okay, so this is finding with the pattern type. It's finding a XRTool staging node, which is that one. I'm guessing that it wants staging in the name here. That's something that was recently added and not done properly. Okay, interesting. Well, we fixed the problem, and that is something I'm putting on my list of things to improve, because that is not what it's supposed to do. Anyway, so here we are. We are, oops. Sorry, I just pressed the wrong button while I was in there. So here we are in that big environment. We can see that we can just look around. We also see that our little title screen is just following us around. This is a protection that if I start looking behind, that I just don't go like, oh, it's all black. No, the startup screen will eventually move into my view. It says now hold trigger to continue. So we hold our trigger to continue. And there we are. We are in our scene that we made. So we can see our green ground. We can see our little cubes for our hands that move around while I move the controllers around. And you know, it's simple, but it's there. So now we need to start dressing this up and actually make it do something more. Okay. So the thing that I wanted to do now is I want to start building out our little controller so that we can actually do more things with it. Alrighty. So the first thing that I want to do here is I want to add to our XR Origin 3D a node called the player body. Now, here is a really important thing that sadly is a bit confusing. In Godot, as I mentioned before, a lot of things work by adding scenes into other scenes, nesting scenes together to create more information. But the other way that we can build a scene out is with the nodes in the scene. So everything that we've added here, this world environment that gives us our background, the light, which is our sun, and I actually want to move that up just for fun. So that is that is the direction our sun is shining. So we can see that our sun is placed there. If we change the way this looks, then now our sun is over there. So we can manipulate our sun that way. So that's a node. The XR origin, yeah, that's a new warning. I don't care. I know that I can't manipulate that. These are all nodes. They're all the building blocks that you build a scene with. And as we did with the floor, we use that little plus button here to add one of those building blocks in, one of those nodes in. If we want to add a whole scene in, so if I go to our XR Origin 3D node and I want to add a scene in here, and the scene that I want to add here is the player body scene, I can do that like this. Oops. And now I have this new scene in there, which is, and if I open that just for fun, it only has one node. It could have had a whole bunch of extra nodes in there. But that adds a whole bunch of functionality in here. Now, the problem that we have, and the confusing thing that we have, is that when we look at the player body, this is a entity called an XR Tools player body entity. And when I go to plus here, and I search for player body, we see that that also comes up. That is something that we are still, we have a solution for that on the horizon to prevent this. Because if you would add the XR Tools player body node without the scene part, it will break. So that is why I went through this little button here and selected the scene, the player body scene, and added it that way. So what is this player body scene, you will ask? Well, the player body scene is the scene that will control our player and add all the physics logic to it and will allow us to move the player around the scene. So the player body is actually a physics object, and we will move that physics object to wherever the player's camera is. And we will make adjustments to the player as required. And this will allow us to create logic like that a player can't walk through a wall, or that a player can climb up a hill or fall down something. Then over here on the right, you will find the properties with which to control the player. So we have a way to disable that logic. By default, that's obviously enabled. And then we have a bunch of properties here for the player. Now I'm just showing this so that you know where it is. For most players, these defaults work just fine. But there are a whole bunch of settings here that you can control. The only one that is potentially interesting, do we have that here? Where's our, oh yeah, we have calibrate high. Oh, that's right. I forgot about that. This one is actually in the settings. So if we go back into our project settings, all the way down, we have an XR Tools settings now. And if we go to the player here, that's where we set our standard height. I was looking for that one in here, but we actually defined that one in the project settings so that they're shared over the different levels that you create. Anyway, as I was talking about in my introduction around XR Tools and the loading screen, this is the height that we calibrate the player at. So even though I'm sitting down and my head is probably at about 1.50 meters, my player will be adjusted so that my head will actually be at 1.85 meters at the start. After that, I can move around, I can duck, I can do all sorts of things, and that height will obviously change. But that will be the starting height at which I'm calibrated. The other interesting thing here is that we have the ability to push things around. So we'll have some fun with that in a second. And there's the possibility to create some more physics properties, but we're going to leave those all for default. Just wanted to highlight that you can configure the player that way, but you don't have to. Now, the other thing is we are using these XR controller nodes here, which just track the XR or the controller directly. But we're going to leave those alone. We're going to leave them here, but we're not going to be using these, or no, we are actually. I just suddenly realized I'm mixing up with the new version that I'm building. But I'm going to remove those test boxes because we want to actually use proper hands and visualize proper hands. So the first thing that we're going to do is we're actually going to change the pose here. We see that by default, we've set the aim pose. That was the pose that we have used for a long time. And just to explain what poses are, when I have a controller here, there are different points on the controller that are being tracked. And right now, the OpenXR supports 3, but 1 is an optional one. So we are only using 2 right now. The first is the aim pose, which is on the tip of our controller. That's the position that we're tracking. And that used to be a point that would be oriented to point straight forward. You're aiming with it. However, in the latest updates on the latest headsets, you will often find that the aim pose actually points slightly inwards to a direction that is more comfortable when you are using your controller as a laser pointer to interact with UIs. So that aim pose is now no longer pointing straight forward, and it is offset differently per device, which has made it a lot less usable. So the one that we are going to be using is the grip pose, and the grip pose is a pose that coincides with this grip button on the controller and is oriented along the stem of the controller so that you know how you are holding it, where you are holding it. And we have logic that we can use that properly. The other thing that I want to do is I want to tick this show and track tick box. And that means that if the headset is not seeing my controller, or if my controller isn't on, or if I'm not using a controller, then instead of that thing just floating in the air in its last known position, we are hiding it. We are not showing it anymore. Now I want to do the same thing for the right hand. I want to change that to the grip pose. I want to do show and track, and that's it. The last one that we have, which is not in the default list, is called the palm pose, which is, well, I actually need to show my palm for that, which is a pose in the center of my hand, of my palm, right here. And that one is also nicely oriented so that it points straight ahead and straight up to your thumb and straight out. So it's nicely aligned with your hand. And obviously, when you are holding a controller, the palm pose is determined by where naturally a hand would be when holding the controller. So that's a very stable pose to use. But because not all headsets support that, we are careful with that one. That is changing, by the way. More and more vendors are making support for that. And yeah, the palm pose is really nice when you can use it. So time to add some more logic in here. And what we want to do is we want to be able to see our hands, but we also want to use the built-in logic in XR Tools that I cannot move my hands through a wall or through a table or something like that. Abstract Doc, I'm sorry, you probably missed this in the beginning. And I know that I got distracted a few times with things that you asked, but I am not taking questions in chat right now. There's a Q&A session at the end of this stream. I will quickly answer that because you did do a super chat here, which I really appreciate, and just simply say that yes, it is possible to only show something in one eye, but you don't do that by hiding it in the eye. You're doing that by implementing a shader on the object where you have there is a variable inside of the shader that tells you whether the shader is being executed for the left eye or for the right eye, and then simply, you can either discard the fragments or you can move something on screen. So, but sorry, I'll answer that one really quickly, but right now I'm not answering things in chat because of this presentation that I'm giving. There will be a Q&A at the end of this. We're quickly running through the time already. All right, so obviously in this empty scene, there isn't a whole lot that we will see here, but we'll resolve that in a minute. But I do want to set this up correctly straight from the beginning. And for that, there is this scene called the collision hand scene that we just drop into the left hand. So this is a special node that will follow the location of our hand but it will implement collisions. We're going to do the same on the right side. So we're going to add that same thing in. Now, the other thing that I want to do is I actually want to see my hands. So the next step, again, with that one, is we're going to go and search for left hand. And there is here a left hand scene. And I was looking at the right hand. So there it is. Now, what you now see, and this is a little funky thing, you'll see that this hand is moved downwards a little bit. Now, as I mentioned, we are using the grip pose. And the grip pose is on that location where the grip is, but it's also aligned with the stem of the controller. So that is at a 45-degree angle. So this is horizontal, basically. This is why my hand is shown that way. Now, as I said before, the actual location of these nodes is overwritten by the tracking system. So we can do whatever we like right now. So we can actually rotate that back so that we can visually see that, okay, the hand is fine. We're going to do that on our right hand as well. Not sure, that might need to be minus 45, but we will see. But now we can repeat the same thing on here on our collision node. Oh, this is also something that a lot of people get wrong when they want to use the collision hand system. If you use the collision hand system, you need to then create everything else underneath the collision hand. A lot of people still place things under that node and then things will go wrong. You have to put it one level deep. So here we obviously want to search for right, and we find the right hand scene, and voila, we have a right hand scene there. Now, there are a number of additional scenes like this which have either slightly more detailed hands or slightly different hands. But for our purposes today, we are just going to have a quick look at using the default hands. We do now need to go back to our collision hands because now that we've added this, we need to assign the skeleton. Now, unfortunately, we don't see it. So the skeleton is the entities inside of the left-hand scene that control the finger positions when we are rendering them. In order to get access to that, we need to select that scene that we added and then right-click and then go all the way down to where it says Editable Children, and then we tick that. And now we see that there's a whole bunch more nodes that are being shown. Those are all nodes that come out of that scene. And here we can see that there's actually a skeleton in there. And we can see that, hey, look at that. There's lots of bones inside there. Those are the bones that we are going to use. So now that we've done that, we can go back to our collision hands. We can assign it. We can assign our skeleton. And there we go. By the way, just to make it clear, I'm using the collision hands because that is really nice on VR. You don't have to use the collision hand system. You can just add the left hand directly to the left hand controller, and then it will just show where it is. And for a AR system that we'll do tomorrow, that's actually more than enough because there it doesn't actually make sense to stop the hand from moving through things. But in a VR situation, that is nicer. Anyway, let's do the same thing for the right hand. So we're going to enable editable children on the right hand. We can now see everything that's underneath there. And then we can go to the collision hand and we can go assign and then make sure that we select the one on the right hand now that we see both of them. And we select that one. All right. I do want to just click on that little fold thing to fold the left hand and right hand just to clear up some space. So now I have hands that will move. We'll see that in a second. But the next thing that I want to add before we do another test is I want to add some movement logic. So again, same thing. I'm going to that thing and I'm going to search for direct movement. So here is a move and direct scene, and I'm going to add that underneath the collision hand scene. There we go. These are good by default, so we can see, well, the order, just leave them. That's just the order in which all the movement functions that you add to things are handled. But the only thing that I really want to see here is, how fast can we move? So this is 3 meters per second. I really should change that to be kilometers per hour, but anyway. And whether we can strafe. So by default, this movement direct, there's two things that are important. One is I've added that under the right hand, and that means that the joystick on my right hand is now going to control my movement. If I would add this to my left hand, oops, not there, there. If I would add this to my left hand, I could now move with my left controller. So one of the nice things about doing this is you can easily switch between left-handed and right-handed functionality, or just change it to whatever the user prefers by moving those things between the left-hand controller and the right-hand controller. And the nice thing with that also is you can do that in code. So you can really make that work quite easily. Anyway, I want it on my right hand, and in its default setup, like here, I can only move forwards and backwards. So I want to go and also take the strafe button. So now I can also strafe left and right with my right controller. On my left controller, I want to add a movement turn function. Now this has a few more settings, but it's the same deal. We can now use our controller on our left hand, our joystick on the left hand, to turn left or turn right. So again, I can obviously turn by turning my head around, but if I want to move around my world and turn around my world without actually moving my head, because I want to move to places that are bigger than the room that I'm in, or because I'm playing this game while seated, I can do that now. Now, I'll run this in the default mode first so you guys can see how that works. But one of the things that we have implemented in here is what's called a step turn delay. And this means that instead of us moving nicely from left to right, which for a lot of people results in motion sickness, we can use that controller to move in steps of a certain number of degrees. And I think I've set it, 20 degrees here. So instead of moving smooth, I will move 20 degrees, and then I will wait for it for half a second, and I will turn again, and I'll wait for a little bit, and I'll turn again. And that is a system that prevents motion sickness. Now, usually you want to make that optional, because a lot of people that are used to VR prefer the smooth movement, but it is something that is nice to have in there. All right, so with all those things in place, let's see if we can now see our hands and whether we can move around. All righty. Cool. So now I have proper hands, and you can see that as I do things with the buttons, my hands move, and now I can use my right joystick to move forward and backwards and right and left. And now I can use my left joystick to turn, and you can see that it turns in those steps. Probably should have done a little lower settings because it's very fast, but that is something that you would want to experiment with and see what feels comfortable. Now for the next time that we run this, I will change the turn mode to smooth so that we can see how the smooth turning works. But yeah, and I prefer the smooth turning myself, but it is both supported. Okay. Now to save us some time, I have created an environment that we can just drop in here to create a little bit of a nicer test. So let's go and bring that in. So I'm going to select our test scene here, and I'm going to go to our room scene here, and we have a room. Now you'll see that flickering here on the ground, and that is because our ground of our room that I just dropped in here is in the same location as that green floor. So if I hide that, that problem goes away. This is called Z-fighting. When things are exactly in the same spot, the rendering engine doesn't know which one to render on top of the other, and it will do that flickering sort of thing that you just saw. Now notice that I do have things on top of my floor here, those little yellow things. They are actually ½ centimeter raised from the floor. Now the other thing that we can see here is this is just a square little room that we are going to use as a test environment. However, funny enough, I'm right in the middle of the room here. And if I would start this hopefully with my calibration, I would start right there, which isn't really what I want. So in order to change my start position a little bit, I should be able to move my origin somewhat back and say, let's go and start over there. So let's quickly test that. Oh, the other thing here is this thing actually has a roof. And with that, I might even, no, I don't care about that. This has a roof with a couple of spotlights in the ceiling. I'm just hiding that because it's easier to work with this when that's hidden. But we'll see when we run it, we'll see the roof appear. So let's see if that's working. Oh, and I need to go and make this big enough. There we go. There we go. Alrighty. Cool. So we can see our little room. There's some little spotlights there. That door is way too small for me, but this test scene, this little play area, was made for somewhat more normal sized, well, not normal sized. We are actually normal sized, more virtual sized games. There's some things around shadows that aren't properly set up, but it's just a start to see what we're doing here. Now, obviously, I can't move into this this table. It's too high. I can't jump on top of that, but you can see that I can nicely move around. Again, I'm using my right joystick. Now, I can look around normally with my head, but as I said, we now have the turn smooth. So now you can see that I can turn around without that stuttering effect. All right, very cool. So now that we have a little bit of an environment that we can walk around in, and where we shouldn't be able to walk through the wall, so we get there. If I try to move through the wall, you'll see that we actually black out the screen. So that is something that's in there, and then I just need to move back from the wall to get back in there. Well, there's nothing outside to see because we don't have an outside environment, but there are some little windows in here. Anyway, the point being is I wanted to have a little environment where we could do something and a table that we can do something with. So I think the next thing that we're going to do is create something that we can actually pick up in our environment. All right, I'm looking at the time, so probably that is the last thing that we will do in this stream, and hopefully that has given a really good first setup of what extra tools can do, because there is lots more in here. But I want to add a few little cubes that we can pick up and that we can interact with and that we can do something with. And again, with extra tools, we are making use of the inherited scene option for this. So in our extra tools folder structure, we go to objects over here. And when we scroll down, we will see a scene called pickable.tscn. So we're just going to go right click on that again, and we're going to go to new inherited scene, and let's just call that a cube. We'll see that there's a little bit of stuff there by default. We have a whole bunch of settings that we can do, but we'll leave them all the way that they are. The defaults all work fine for us. So we're going to add a mesh instance here. We're going to give that a box mesh. There we have a cube. Now we don't want such a big cube, so we're going to make that a bit smaller. There we go. Let's give this thing a material as well so that it looks a little bit nicer. And the material that I want in this case is, again, our little pattern material. And let's give our box a little bit of a nicer color. So let's make it blue. And there we go. We have a nice blue box. Now, the other thing that we want to do is give it a collision shape. In order to be able to pick it up, we need to give it a collision shape because we're using the physics engine to detect where the box is. And the nice thing is that the size properties of the collision shape work in the same scale and in the same manner as our cube, our mesh instance. So we now have a nice cube with a collision shape that would allow us to pick this up. Cool. And the next thing that we want to do here is we want to make sure that we highlight this cube as we come close enough that we can pick it up. So for that, we need to add a Actually, I'm not going to use the highlight ring. In this case, it's actually a function that we can add through our plus option to add actually a node here. And what we can see here is we have that highlight ring. That is the one that we would need to use through a scene. That shows a little ring whenever we get close, but we want to actually highlight the cube. So we're going to add this Extra Tools Highlight Visible node. There we go. And what we're simply going to do is we're going to create another mesh instance here. And that's going to be another box mesh. And that's going to be actually, that can be the same mesh as we do here, if I remember correctly. Let's see. In the new version of Extra Tools that I'm working on, this is actually automatic logic. But I suddenly realize that we have that special here. So what I've now done is there's a material on our box, but on our mesh instance, we can override the material that we're using. And the material that we want here is a special material that is hopefully in our standard materials. I guess not. So we're going to have to create a new, can I not cancel this? Why can I not cancel this? Well, oh. Clear. Hold on. Am I remembering this correctly or not? Sorry, let me really quickly check this because I'm starting to wonder if I'm doing something the wrong way around. No, it is that way around. I am correct. Okay. So I'm surprised. I thought we had a default material for this, but it's very easy to create the material that I want. So I'm creating another standard material here. In this case, I want to make that nicely yellow. I want to, let's see, where are you? I want to use the grow function to make it ever so slightly bigger. That is too much bigger. And now I want in the shading, is it in the shading? No, it's in transparency. I want to change the cull mode to front. And what this will do is create this little outline. I want to make that a little bit more pronounced. So let's make that 2. Cool. So it creates this little yellow outline around the box that will allow us to see where we can pick it up. Now, I'm going to do this slightly differently because I don't really like the way that it does it with the grow. So we can create the same effect by just increasing the size ever so much. Okay. Oh, shit, that's right, because, haha, okay. We're just going to create a new cube for this and make that the right size. I forgot that those things are linked. So like I said, I am working on a newer version of Extra Tools where this sort of logic is built in. But yeah, so that gives a nice little highlight in the back. And the nice thing about this approach is this node is basically a node that becomes visible when you are in range of grabbing this object. And you can decide yourself what you want to do in order to visualize that effect. So right now I am just creating a slightly larger box. And actually the last thing that I want to do is in shading, I want to make this unshaded so that it's just a single color. There we go. And I want to make it a little bit brighter. There we go. So I'm now doing this by creating a slightly larger box around my box that is inverted and is yellow to make that visible. So we'll see that this becomes invisible when we are not close to our box and visible when we are close to our box. And that allows us to know that we're about to pick up our cube. So let's go and create our cube scene. I'm going to put that in our test scene here because it's part of this test scene. And this should be enough for us to pick up this cube. Let's go and add our cube in there. So in order to add our cube in there, we do our add scene again, and we create a cube. So there's our cube. I'm going to move that up, and please don't do that. I'm going to move that up. I'm going to move that back a bit. Okay, too far up. So I'm just going to put our cube here. I'm going to rename our cube to cube 1. And I'm going to use Control-D to make a duplicate of that cube. So now we have 2 cubes. Now we have 3 cubes. Let's go and put them there. And when our physics simulation starts, these should fall nicely onto the table. All right. We do now need to tell our player how we can that we can actually pick things up. And we do that the same way as we did our movement turn. We go and select our collision hand. We go to here and we search for pickup, and we find a function pickup, and we just add that in there, and that adds all the logic that we need that will allow us to pick up an object. And we will pick it up by default by pressing the grip button on our controller. So I'm going to do that on the right hand too. I'm going to add a pickup function there. So now both our hands will be able to pick up our cube. So let's go have a look at that. There we go. Let's make sure that that is full screen. There we go. There we go. Perfect. So I am now in my room. I do need to scroll or move back a little bit. Should have really done something about the shadows. And now when my hand goes close to these cubes, actually I can actually manipulate the cubes. I can move them around like this. Oh, that was accidentally pressing my my button. I realize that I am a little bit low at the moment. But yeah, so I can physically manipulate them by just touching them with my hand. But also when it is highlighted, I can press my button and I can grab the cube. Now what you will see by default is the cube will be grabbed at whatever position it was when I press that button. So that is the default behavior that we have here, but we can actually have some control over that behavior. So let's do that as the last thing, and then I think it is time to do our Q&A session and hopefully answer some questions. So the last thing that I wanted to show is if you want to have control over that, you have 2 options. Hey, Post, what is it? My cat wants attention. The first is that we can change the grab mode that we have. No, I think that's actually on the function pickup itself. Hey, cat. Triggers. Dang, I forgot what that was called. That's fine. Maybe we remove that option. I guess we remove that option that we always have to use the grip, because normally there was an option that it would always grab it at the center of the object. It's a pretty useless thing. But the other thing that we can do is we can add in a grab point. So we can see here that we have a number of different grab points. But for our hands, we have a grab point left and a grab point right. So let's start with our grab point left. And we'll see now that we have the ability to, oh, just make it visible. We have the ability to see this, this hand. Now, because the system was originally designed around the aim pose, the location of this is actually where our aim pose would be, but we can just properly put this in place where we want the hand to be when we grab the box, and it will adjust it to where the grip pose is. It'll do that properly. What we can also see is that we're making a fist here, and that is handled by our hand pose. So this is our default fist that we're making, but we have a whole bunch of these that we can do. So on this property called hand pose, we can add a new hand pose here. Hold on. Let's just do load itself. No, that's not the one that I wanted. Just a normal load. XR tools, hands. And I think that's under animations. Yeah, there we go. But those are just normal resources. Hold on for a second. Default left. Oh, we just need to create a new one. That's right. Let's create a new one. So we can select different hand poses here. We have a whole bunch of them. So when we open this, we can find, and actually want to search here for the left hand. So we have these all for left and right. And we can select one here. So let's just for fun, just for craziness, we're going to do our horns one. And I also want to do that one for my, oh, actually, I'll do both horns. So there we go. So we can see that we have this crazy horns little pose that we can have on our hand. So we have these two poses that we set. The open pose and the close pose. And all that this allows us to do is to swap between the pose that we want to have when our trigger and our grip button is pressed, and which ones we want to have when we are not pressing that. So closed means when we grab, we have a closed hand. Open means open. And let's actually, just to demonstrate that, let's grab a different one for this. I just want something, just, do we have a complete open hand? Should have an open hand in here. Yeah, just do the default one, I think. So the default one is open like this, and the other one is closed. And what we'll see when we are holding this, we will actually be able to manipulate one of our fingers to go between the default pose and that one. Let's do the same thing for our right hand. So we're going to search for grab again, and now we're going to do our right hand grab point, and we're going to make that visible. And we're going to quickly move that in place. There we go. There we go. Make it a little bit closer. I realize the time that I'm going through this a little bit quicker. But here I need to obviously look up the ones on the right. So I just want to do my default grip. So that's the pose that probably is a lot better for this purpose, where we are holding our cube properly like that. But for open, again, I'm going to use the default pose again. There we go. So that we can see that work properly. So we now have those two. I do want to hide them again, because why would we want to show them when we're not using them? And I'm going to test it out for one more time. There we go. All right, cool. Sweet. Okay. Oh, yeah, there we go. Took a minute for it to realize that I've got controls. Need to sit back a little bit again. And so now when I grab that cube, you can see that we have that grab pose, and you can see that I can manipulate the other finger between the close pose and the open pose with my trigger. Now I should be able to, oh, I forgot to add the two-handed mode. So let's just grab it with the other one. We see that that horn signal that we have. And I can move my finger, but it can only move it a little bit, because the default pose and the horn pose is very close to each other. Now, for the two-handed thing, I'll just quickly just mention how that works, but we won't demo it because I think we've run it out of time at the moment. But yeah, the only thing there is when we look at our grab pose, we can show here, or we can select here this mode between general, primary, and secondary. So general really means that we it just works by default, but we can switch between a primary and a secondary hand, where we can say, well, with this one, I primary grab it, so I would actually have to duplicate these, but it's really meant for if you want to hold like a stick or something, is that you you have a set of grab points where you want to be able to grab it as the primary when you hold it. And then the secondary, you have another set of grab points that you mark as a secondary where you can then grab that object with your other hand. And now we will be able to manipulate it in that way. But we've run out of time to show that off. But I'm hoping that, this was a good, at least this was a first introduction of, okay, what is Extra Tools about? How can you start building things in Godot using this toolkit? And where can you get started with this? There is a whole lot more in Extra Tools to cover. I've got a whole series of videos on my YouTube, and some other people have gone there as well. So yeah, I'm hoping that this gives a good first look at, okay, how does this work? How do you put things together? And where do you get started? For anybody who's interested in this and wants to do much more with Extra Tools and wants to know, okay, how do all the other functionalities work in Extra Tools? The best thing that I can advise is either through the asset lib, and I'm not quite sure if I can select it here or only on the no, I can't select it here. I can only select it on the create new project scene. But it's either create a new project based on that XR template, or to go to the asset library itself and download the demo that we have. There's a demo project. Actually, I might really, just as the last thing, I might quickly open that up. So if I go back to the project list, because I think this might be, just as a last thing, really interesting to just show you what it looks like. So I've got it under here. Where is my asset folder here? Extra Tools. So if I open this one, yeah, it should be fine. Go and convert it. It's fine. Just give that a quick moment to load. Sorry, this is all full screen for you guys now, but oh, come on. Can I hide that, please? There we go. Let's make a little bit of room. So this is one of the demos that is in there. So this is a big demo project that has a whole bunch of separate scenes in there that you can go between. So when it loads, it actually loads into, where are you? Main, into the main menu scene. So I'll just quickly show that. So you'll actually load into this environment and you see all these teleporters everywhere, and you just walk into one of those and it will take you to that demo. So the one that was open is called the Pickables demo, which basically shows everything that we just went through in this presentation, and it shows you, that you can pick up a whole bunch of things. So these hammers are two-handed. There's a rifle here that's two-handed. So those are examples of two-handed things. And yeah, there's lots of things to look at here and see how they work. You will see that there are many demos here that show all sorts of different capabilities of the XR Tools toolkit, from just the movement stuff that we handled, to grappling if you want to be Spider-Man, to the interactables demo is something that a lot of people are interested in. So this shows you how you can manipulate levers and buttons and all that sort of jazz. So yeah, just wanted to make you guys aware of that before we go to the questions. Let me just go to the window that Inigo has put a whole bunch of questions in there for me. So I will just go through them. I will read these out and try to answer them the best as I can. And then we'll see if there's anything left in chat that we want to deal with. And then hopefully, yeah, we are there. So, Nico, thank you for thanking me. That's always really welcome. I'm really hoping that I was unable to show enough in such a short time frame. So a very positive aspect of Godot is its integration with Git and how easy it is to clone projects and get them working right away. In this regard, could you give us some recommendations on good practices on using Git to track Godot projects? Do you implement feature branches to develop scenes? In general, what would be a good way to go with Git in Godot? So for me personally, I'm old school, so I use Git a lot through the command line and work through that. So I don't actually use any of the embedded tools that we have. So I can't really answer that part of it really good. But as far as how you organize your Git processes, yes, you would work in pretty much the normal way that you would with any other development environment, where you would just create a branch. You would make your changes in that branch, and once you're happy with that, you merge them back into your game project. Now, there are a few little gotchas to have there. Obviously, as a solo developer, it becomes much easier to handle. But when two people modify the same scene, you can get into each other's way. Now, one thing that is really, really nice is all the scene files and script files and all those things, they're all text-based, they're all human readable, and that makes them very resilient to doing Git merges and things like that. But there are things that you can obviously do inside of a scene, that if two people modify the same scene files and you try to merge those, that you get a situation where Godot doesn't know what to do with the end result. So again, I highly recommend working that way, but there are a few gotchas that you have to be careful with. And as long as you are aware of that, most of the bigger teams that I know use Git to develop Godot with, and they learn very quickly what to do and what not to do, and it's a really, really solid workflow. And even if it goes wrong, it takes very little effort to understand the scene format, and you can usually quite quickly find out just by looking at your change logs what went wrong and how you want to fix it. So absolutely feel that that is a strong suit of how Godot projects are organized. In the lab, we have a bunch of different devices: MetaQuest 2, Quest 3, Quest Pro, Pico, and Pico Neos. Do you think we should focus on one device, or is it a good idea to pick several different models? Of course, brands that are supported in Godots. We pride ourselves that we are as portable as possible. So what I've of course have shown off today is all PCVR. But because we are using OpenXR, the only real problem that you might run into is performance. Obviously, if you develop something with the Quest 3 in mind, and you then run it on the Quest 2, you might run into some issues. The other thing, of course, is that there are differences between these devices and capabilities. So if you are using something that is specifically supported only on one device, like what we're going to be looking at tomorrow with Scene Discovery, which is only really supported on Quest Pro and Quest 3, you obviously need to be aware that you can't port that over to one of the other devices. The only one on your list that I would recommend not using with Godot, or where the support is a bit dingy, are the Pico Neos. We are on the latest version of OpenXR, and Pico has fallen behind a little bit on there, as far as I've heard. I don't have a Pico Neo myself, but I've heard from a number of people who are using Pico Neos that they do run into some compatibility issues. I do have a Pico 4 and a Pico 4S, which are both brilliant devices to use with Godot. So yeah, the message is you can use Godot on all these devices, and as long as you stick with the standard OpenXR functionality, your application will be very portable between those devices. You can build something for Quest 3, and it will very likely just run on a Pico 4S, or if there is an issue, there is usually knowledge on how to work around or fix that issue. So that's a good moment to come onto our Discord and ask some questions, and usually we have an answer for that. A curiosity-driven question rather than about Godot itself. Steam Frame is to be released soon. Do you think this is going to be a game changer, or do you think that Meta is going to focus on interaction, social media, metaverse, while Steam Frame market is going to be focused on game development for PC VR? Okay, I need to be very careful with answering that question because I am under restrictions to talk about certain things around the Steam frame. Uh, but in general, I do think it will be a game changer. I am slightly worried about where the world is right now, price wise, because obviously price is going to be a big factor in how successful it is. But the thing that I am myself and most excited about is that Valve is clearly providing a focus on games, and that is something that's been missing. I personally believe that VR didn't die or was unsuccessful. I think that we have a big PR problem in the VR space. That because the focus by all the other big vendors has all been on MR and AR, VR got sort of forgotten almost. And because of that, there is a limitation there. So I personally feel that once the Steam frame launches, and with the Steam ecosystem, that could potentially lead to a revival in the VR space. Now, that is not to say that the focus on MR and AR and spatial computing, or whatever the latest buzzword for it is, was the wrong thing to do. I think it was premature, but I don't think it was a wrong thing to do. I think those sectors are going to be very big in the coming years, especially now that a number of vendors have announced their glasses format versions, where you can have like a glasses type device with displays. I think that is going to be a resurgence in that market, and that's going to likely grow fairly quickly. Is my feeling about it. But yeah, I strongly feel that VR could have been bigger today than it is if we had a different focus in the market, and I'm really hoping that Steam Frame is going to make a difference there. But we will see. Regarding cyber sickness, what strategies are implemented in Godot to avoid motion sickness? We know about the fading node, teleporting strafe, and discrete turn for rotations. Are there any other properties in Godot to reduce motion sickness? So important there is that Godot is the box of Legos, right? So Godot itself has all the components for you to make an application that is that caters to either does or does not cater to motion sickness, because you can make the choice to not do it. And there are many VR developers who say, I want to make a game, and you can only play that if if you don't care about motion sickness or don't care about those sort of techniques. So Godot itself is a box of Legos. It allows you to implement that or not. Extra tools is where we have put in various systems to combat motion sickness, the turning being a good example. We did not have time to look at the teleport, but there is a teleport first function in Extra Tools that allows you to move to a different location in your environment through a teleport, which is again something that for many people fights motion sickness. But many of the things around motion sickness is about knowing what it's causing it and knowing how to structure your game to limit the amount of motion sickness that you have. A lot has to do with how you place things in the world, how you can anchor a person in the world, and more importantly, also what not to do. So it really is up to you to use the tools in the correct way to combat those sort of things. Cool. I hope that was clear enough. I'm going to have a quick look at if there's anything in chat that I need to focus on. I don't think so. I already answered the visibility of one eye, so that is a setting in the shader that you can use to only output something to one eye. I think other people have already answered the questions around virtual desktop and Linux. Only have one. Oh yeah, the whether Voviation also use lower lot models. No, it does not. The lot model system in Godot is separate from the Voviation system. So we do support the ability to show lower LOD models as they are further away. But that is just a standard system in Godot that's not tied into the XR system. All right. There are AI-generated 3D Explorer spaces at Love, Lyra 2 used in VR. Well, I haven't really tried them out yet. I'm still on the fence of whether I like it or not. We will see how that goes. All right, cool. Inigo, do you still have anything that you would want to add to this session, or everybody is everybody happy about covering everything that we wanted to cover today? Just gonna wait for a few seconds to see if there's a reply on the Discord there. Unfortunately, there's always a bit of a delay on YouTube. That's just the way that YouTube works. So. Cool. Well, then I'm going to call it there, people. We're nicely on the 2-hour mark, which I'm really happy about. Yeah, time flies when you're dealing through these sort of things. Just wanted to remind everybody who's watching, including the students over at the university, I am always reachable on Discord. So if you have any questions, you can obviously give them to Inigo and he will send them through to me. I'm happy to answer more questions even after this session is done. And otherwise, I will hope to see everybody again tomorrow when we're going to have a rapid look at AR functionality in Godot. So thank you all for watching, and yeah, I hope that that you picked something up, and I hope that it has convinced a few people to play around with Godot and give extra tools a try. So cool. Thank you so much, everybody.